Hi class, Dr. Searcy here with the video lecture for the textbook for chapter 6. And as you can see, the title of the chapter is probability. Again, we are moving into a new direction beginning with this chapter. So I want to just review some information that's important to remember as we look at this new information for chapter 6. First thing that you want to remember is what we've been saying about z-scores. Right, so remember that the way that I introduced the z-score is it is similar to a standard deviation in that it's another way of thinking about some standardized distance from a mean. And the way that we figure out a z-score is you use some kind of information, like maybe a raw score, a mean, and a standard deviation to calculate what the z is. In this calculation, we're going to say that we've got a division problem where in the numerator, we are subtracting the average from the raw score, and then we're dividing that by the standard deviation. And as you can see, I am showing you both the population format of the equation and the sample format of the equation. So how do we think about the z-score in terms of our graphs or our distribution, specifically our histograms? Well, the thing that you want to remember is that we draw these histograms, and the one purpose that we have in doing so is to then draw that curve over the histogram that represents the shape that the bars make. When we do that, remember that we then talk about different rows of information that are below the x-axis. So I'll make sure to describe these for you again so that we remember how these things work. The first row that we're talking about is the x-axis row, and that's where the range of x values are for the different bars in the histogram. But then below that, we talk about the mean of the distribution. And the important thing that you want to remember with this is that we always say that the mean is exactly in the middle of the distribution underneath this mean line. From there, then we always talk about the standard deviation. That's the next row that's going to be below the mean. And the reason why we're putting it below the mean is because we can stack our information there in a way that's organized. For instance, remember the whole definition of standard deviation is we're talking about some standard distance that numbers move away from the mean. So when we talk about those standard distance, we're talking about these standard units that we have. And the way that we identify how far that standard unit is from the mean is we look at, well, what is the value of the standard deviation? In this example here, we're saying that since the standard deviation is 2, then each of our 2 standard deviation points of 1 are going to be 2 ticks away from the mean, right? So here we have a standard deviation of 1 above the mean at x value 35, and then another standard deviation of 1 below the mean at x value 31. So then that's when we say that we're talking about z's as well, right? So z's can be thought of as another number line underneath the x-axis. And this number line lines up exactly the same way that the standard deviation line lines up. One difference that you might see is that if you remember from us introducing the z-scores, we said that when you have a z that's got a negative value, that means that that z-score is somewhere below the mean. From there, the thing that you want to remember is, well, what's the purpose of calculating z? Why are we doing that? Well, the reason why is because we're interested in finding a z for some specific x that may not be specifically identified in the standard deviation line, right? For instance, maybe like, in this case, what would be like the z-score for maybe x value of 34? We use the z equation to tell us exactly what z value would go right there underneath that 34. And with that, it gives us then a sense of where any x value is in terms of z values. Okay, so from there, I have another item that I want to review with you. It's really not something that we've talked about in this class, but it probably is some information that you've come across in life, and we just want to make sure that you understand it because we're going to use it in this chapter. So what is that other piece of information that we're going to review? Basically, we're going to talk about, well, what are these two symbols and their meaning, right? So the top symbol is the greater than sign, and the bottom symbol is the lesser than sign. And basically the way that they work is, say you have a 3 and you want to have some other number that you're comparing it to, like say maybe a 1, you would use the greater than sign to say that 3 is greater than 1. However, on the other hand, if say you have a 1 and you want to compare its size to a 3, then you would say that the 1 is less than the 3. Okay, so we just want to remember that logic of how we use the greater than and less than signs. From here, let's go ahead and start to talk about the topic of the chapter, namely probability. Okay, so first we should think about defining what we mean by probability. In this case, I'm going to give us a mathematical definition of a probability. In this case, we're talking about probability being represented by P, and we're saying that we can acquire that value by a specific equation, and the equation is where we pick some x value, right, some random number, and we divide it by the total of the collection of numbers that that value came from. Let's think of an example to help understand this concept. Let's say we wanted to think about a probability example, and that probability example had to do with a deck of playing cards, right? Like maybe the cards that you play poker or blackjack with. What if someone came along and asked you, what is the probability that I would pull a spade out of that deck of playing cards, right? So with that, we're talking about a specific suit within the playing cards, and we're asking, of the total number of cards in the deck, what is the probability that we pull one card out that has the spade suit on it? Well, to answer that question, we need to have some relevant information. Basically, one thing that we would need is the number of spades that are in the deck. And then the other thing that we would need to know is how many cards are there total in the deck, right? So let's just say the division problem would be something like taking the number of spades and dividing that by the total number of cards in the deck. Okay, so if we find those two values, we discover that they are 13 and 52. There are 13 spades in a deck, right? So you got your ace, and then you got your 2 through 10, and then you've got your jack, king, or jack, queen, king, right? So that adds up to 13 spades in a deck. How many cards are there total in a deck of cards? There are a total of 52. So here now we're saying that we have a division problem that will tell us what the probability is of pulling a spade out of the deck is. We can go ahead and solve the division problem. One way that we can do it, though, is we can think of it as being a fraction. And if we think about it as being a fraction, then we can say that this fraction of 13 over 52 reduces to 1/4. From there, we can also see it as like a division problem. And that division problem would give us some value in terms of proportion, right? So 1/4 is 0.25. And then remember, and we were talking about proportions, we could take that decimal value and we could change it also into a percent, which would be 25%. And we get the 25% by just moving that decimal value over to the right 2 spots. Okay, so This is the general idea of what we're talking about with probability. And researchers use this concept of probability, this specific concept of probability, when they think about the research that they've conducted. For instance, a question that they might ask is, what's the probability that I'm going to reach into my normal distribution and pull out some x value in particular? By the way, I do want to note that this really only works with normal distributions or smooth distributions, right? The reason why that's the case is because when you have a smooth distribution, there are assumptions that you can make about that distribution. And those assumptions are basically illustrated with these two pictures here, right? So here I've got a picture of gold flakes being dropped onto a pile of gold flakes. And what you're seeing is as the more gold flakes fall onto the pile, the more of a normal distribution it starts to acquire. We're seeing that same kind of thing here with the Peanuts gang and this pile of leaves, right? So the pile of leaves had a constant barrage of leaves added to it. Eventually, it took on this shape, right? So that's like the assumption that you can make. The normal curve is going to take on a specific type of shape. So when you're able to assume those assumptions, then you're able to assume things about the probability of pulling out the different values out of the distribution. So let's talk about how this is going to happen in chapter 6. Basically, in chapter 6, you're going to start to see questions like a certain type of probability question. And here I'm saying the probability question we will ask is going to, I'll go ahead and put a colon there. It's going to look like this question. What is the probability that I will select X, right? So what is the probability that I'm going to get a hold of some data, I'm going to pull one X value out of that data, and it's going to be a specific X. One way that you're going to see that kind of question being asked in the chapter is like this. For example, P represents probability. So this is asking, what is the probability that I'm going to pull out a specific X and it's going to look like this? What does look like this mean? What is the probability that I'm going to pull out an X that is greater than 4? Right, so again, this is just a hypothetical situation. I'm saying that I've collected some data and maybe I've got a bunch of X values that range anywhere from maybe 1 to 10, right? And the question is, of all those X values that I've got that range from 1 to 10, what's the probability that I'm going to pull out a 4 from that group? Oh, no, not just a 4, but what's the probability that I'm going to pull out some X value that's greater than 4, right? So what's the probability I'm going to pull out a value that's say from 5 up? Okay, so the way that we think about answering this question is by following a series of steps that we need to answer. And I'll go over those steps with you now. A first step would be to sketch the curve, right? To sketch the histogram and the curve that's representing the data that you're talking about. You want to do this so that you get some idea of exactly what you're talking about. How it gives you this visual idea of what it is that you're talking about. So in this example, we could say that the curve might look like this. Let me cover those other steps up real quick. Okay, so the curve may look like this, right? And just remember, this is completely hypothetical, made-up data that I created for this lecture. But we're saying we are looking for some X value that's greater than 4, and we want to know what is the probability of that happening. So what we're going to do is we're going to draw our curve. We're going to plot where that 4 is on the curve, and then we're going to place it around its relevant data. For instance, one thing that's important is to know, well, what's the mean of the group, right? And from that, we get a sense of how far is that 4 from the mean. In this case, we're saying that it is not very far. As you can see from below the curve, we have the standard deviation of 2, which means that the first standard deviation unit going in this direction from the mean is at the tick mark of 5, or x5, x of 5. So this 4 here is like right in the middle of that standard deviation unit, right? We could see that visually. Now what we're seeing is, in sketching the curve, we're also starting to get a sense of exactly what does this mean? What does the x greater than 4 mean? Specifically, what this means is that we're looking for some probability that we're going to find some x value, not just at that 4, not even at the 4 really, because it's greater than 4. We're looking for the probability that we're going to find some x value in this part of the data, right? This shaded part that I've got here. That's what we mean by x greater than 4. If there's 4, we're looking for probability that there's going to be some x that we're going to find that's in here, right? So that's why we've got this area shaded off. Okay, so now what I've done is part 2. I have identified the area of interest. In this problem, we're interested in knowing about this part of the curve. By the way, I'm referring to this part of the curve as the tail. Why the tail? Because it got this part here. One thing that you might note is that when we talk about a tail of a curve, it can be on the right side of the curve, or you could also be talking about the tail on the left side of the curve. In this case, the reason why we're talking about the tail on the right side of the curve is because we're talking about values that are above the x, greater than the x, so on this side of the x. And also on this side of the 4. Okay, so with that, we've identified our area of interest. Now we want to know, okay, well, how do we answer the question? How do we find what that probability is? Well, step 3 helps us to acquire that information. Here in step 3, I'm saying that you're going to take that x value, right? So that x value that you're interested in this case that 4, and you're going to turn it into a z-score, right? What I mean by that is I mean that you're going to find the z value that corresponds to that 4. And you're going to use it as like a marker of where at least you're going to start, right? If we're saying that I want to know what's the probability to find a value greater than the x of 4, then I have to know where the 4 is in terms of the z's. Okay, so how do I figure out what the x value of, or what the z value of 4 is? Well, that's what we learned in chapter 5, right? You learned how to conduct z-value equations. And here are the numbers that are going to go in the equation. To make sure that you see where I'm getting these numbers from. First, remember that the 4 is the x value that we're interested in. The 3 is the mean, and that's the value that's going to get subtracted from the x, right? X minus the mean. And so then that 2 then is the standard deviation, and that is what we divide our numerator by. So in this example, we end up saying that 4 minus 3 over 2 is going to equal 1 over 2. From there, we can just go ahead and say that that's a division problem, and we end up then with a z-value of 0.50. So now at this point, I know what my z-score is for my x value that I'm interested in. From here, I still have to get a sense though, even though I know now that that's a 0.50 there, I still have to know, but what's the probability of pulling something out of this area greater than that 4, now greater than that z of 0.50? Well, the way that we figure that out is we now have to consult a table of numbers. And that table of numbers is referred to as the UNT, the unit number table. And I'll just show you how we can do this just with the purpose of solving this problem. The unit number table is a table in the back of your textbook on page 647. This unit normal table has columns of information that we're going to use to help us figure out this answer to this question. So remember what we've done so far is we've said that our x value of 4 is equal to a z value of 0.50. And then from there, on that 0.50, we want to use it to figure out what the probability of pulling something out of that area of the curve is. Okay, so the way that we're going to do it is we're going to go to our unit normal table. We're going to first look for the z that we have calculated, right? And see, you're seeing the z column here. You're seeing that there's a whole bunch of z's that move in this numerical order. I'm looking for that z of 0.50. I don't see it on this page, right? The range here is from 0 to 0.49. So I'm going to flip a page, and I'm going to see that my unit normal table continues onto the next couple of pages. From here, I'm now going to look for that z of 0.50. I'm going to find it right here on the top of page 648. Once I've found that z, now I've got these 3 decimal values that correspond to that z. And you're saying that each decimal value is also a specific proportion of the curve, right? So this proportion of the curve is how much is in the body, how much is in the tail, and how much is between the average and the z-score. Okay, so the number that I'm after is this idea of finding what probability there is of finding this x value in the tail. So I'm going to go to that number in the middle under proportion of the tail, and I'm going to say that that's the number that I'm looking for to answer my question here. Here it is a 0.3085. Okay, so then in answer to this question, what we're saying is the probability that I'm going to reach into the data and find an x value that's greater than 4 is going to be equal to that number that I just found, that 0.3085. Basically, what this is telling you is that is how much of the data is present in that chunk. Like the proportion 0.3085 of that whole of 1. Another way that you can articulate this is you could also say that it is 30.85%, right? Or now what we're saying here is the probability that I'm going to reach into this set of data and pull out an x that's greater than 4 is 30.85. There's a 30.85% chance that I'm going to pull an x out of here. How am I saying that? Because I set that 4 as my boundary, and I said that it's going to be above that 4. And so I just said, okay, now I'm going to find a standardized boundary. That was that z-score of 0.50. From there, in my unit normal table, I found what percent of the whole curve is in that little part of the curve that we're referring to as the tail. Okay, so that's basically what we're doing in this chapter. We are receiving these questions like what's the probability that I'm going to find a specific x, and then we're using these steps to answer that question. Let me go ahead and offer a bit more of an explanation of this unit normal table that I've just introduced to you. And the way I'm going to do that is by first noting that that unit normal table spans the pages from 647 to 650 in your textbook. Right, so here is my 647. We could say this is where the unit normal table begins at a z value of 0. And then basically what it's doing is it's showing you all the different z values all the way to the furthest point away from the mean. And let's see what that furthest point away from the mean is. If we look at the end of the unit normal table, we're seeing that that last value is at a 4. Right, so basically what this is saying is that if I have some curve that I'm talking about, the ranges in that unit normal table span from a standard deviation value of 0 all the way out from 1 standard deviation unit, 2 standard deviation units, 3 standard deviation units, to 4 standard deviation units. It shows you all of the z values within that range. Okay, another thing that you might want to note, though, is in that table, it does not show any negative z values, right? So in this moment, you might be asking, well, what about those negative z values over here? Well, all you would do is, if you wanted to find some information about a negative z value, you would use the positive z value because they mirror each other, right? So whatever information you get about a positive z is going to also be accurate for a negative z in the opposite direction. Okay, with that though, I do want to make sure that what you're seeing here is that that unit normal table lists z-scores, right? And so that's this first column in the table, right, before the other 3 columns. Okay, so with that, then let's think about what we do with this unit normal table. And I've got this example of a cutaway chunk. When we use the unit normal table, we use z-scores to find proportions of interest, right? So we just used the z-score to find what this proportion of interest was. How do we do it? We did it by using the tail number that was at the z value of 0.50. Okay, so something that we want to see with this is, whereas we just looked for this area that we're referring to as the tail, you can also use the unit normal table to find other parts of the curve as well, right? So that's an example of what we just did right now. We looked for some area under the curve that was a relatively small area on one side of the curve. We also, though, might be interested in looking at the body of the curve, right? So when we're saying the body, now we're talking about where most of the data is, right? Think, for instance, there is the mean line there. Here, we're thinking of the body of the curve as being that total 1/2 of the curve plus another chunk of the curve as well, right? Notice how the body is saying like most of the curve, and the tail is saying just a small part of the curve. Another way that we can say that we want to find information about where x value might be is we might want to say, well, I want to know what's the probability of finding an x somewhere between the mean and then a specific z value, right? So that would be between the mean and a specific z. Then we would use this column here. Okay, so when we go to answer the different questions, you want to have a sense first of which part of the curve am I looking for this information in. Once you've decided that, then you know, okay, if I'm looking for this proportion that's in the body, then I'm going to look in this column once I've found my different z units. If instead I'm looking for the proportion that's in the tail, then I'm going to be looking in this column. However, if I only want to find that area between the mean and a specific z, then I'm going to look in that column. Okay, so that's our explanation of how we look up information using the unit normal table. Now I just want to spend some time going over some practice probability questions that are some examples of the kinds of questions that you'll see in this chapter. And the way I'm going to do this is I'm first going to show you the problem, and then we'll talk about how we solve it. So here is a kind of problem that you might see in your homework. This is saying, what is the probability now that I'm going to find some z that is greater than 1? Right, so before it was the probability that I'm going to find some x value, right, and there was some information here. Here, what we're saying that we've done is we're no longer looking for the x. We are now just looking for the z. So it's almost like we've already done the job of converting the x value to a z value. Now we just want to know what's the z that we're going to find here. Okay, so in this specific question, they're saying, what's the probability that I'm going to find some z that's greater than 1? Remember that what I said was in finding the answer to the problem, you're first going to sketch out the curve, right? Just give you a sense of, well, what are we talking about here? What are they asking us to do? So when we sketch out the curve, we basically see that it looks something like this, right? We're being asked, what's the probability that I'm going to find some z value greater than 1? So that means what's the probability that I'm going to reach in and pull some z value out of this area of the curve? Okay, so now what we've done is that second part, we have identified the area of interest that we're talking about in the curve. Basically the same thing as we did here, except instead of having to go and find x, or having to use x to find z, we've already been given z. Okay, so now our job, right, so let's see what we've got here. Now our job is to go to that unit normal table. When we get there, now we're going to go look up that z that equals 1. So I'm going to find that in my book. I'm seeing that that is right here on page 648. And because we've said that I am only interested in this part of the curve, right, this small part of the curve, I'm only interested in finding the proportion in the tail. So I'm going to then my C column here for my Z of 1, and I'm seeing that I've got a 0.1587. Okay, so what am I going to do with that 0.1587? Well, it's basically our answer to the question that we're being asked. And the way that's the answer is we're saying that we've just gone to column C and we found that 0.1587. That ends up being the answer to this probability question. Now we can say the probability of finding a z greater than 1 is 0.1587 or 15.87%. Another way to say that is 15.87% of this entire curve is this chunk right there. Okay, so that's the type of problem that we're going to have. Let's just note that this is the kind of answer that you'll be looking to be able to provide. And then you'll also want to see how you got that answer by using the unit normal table. So then I do have a couple of other practice problems that we can go over. First one is going to say, now, what is the probability that I'm going to reach into my data and pull out a z that is less than 1.50? Right, so just to help us see what we're talking about, we're first going to draw that. We're going to sketch out that curve. And this is what it looks like this time. Right, so we have a curve that we've drawn. We've found where that 1.5 is. Notice that I'm saying it's a 1.5 on our standard deviation row. But the reason why I've left it like that is because you want to remember that we could say that we've got a z value row right underneath that, and they map right on to each other. Maybe one difference is that instead of having a positive one below the mean, you would have that negative one, right? But other than that, for our question of interest, the 1.5 z is going to be right under the 1.5 standard deviation. From there, you'll notice that when you look at the curve, I've shaded most of the curve. Why have I shaded most of the curve? Well, because the question is asking, what's the probability that I'm going to reach in, pull a z that's less than that 1.5, right? So if it's less than, what's the probability that I'm going to pull a z in this part of the curve? Now, one thing that you're going to want to notice that's a difference between this curve and this curve is here, we're talking about potentially pulling out a z out of a larger chunk of the curve than we did up here, right? Remember, so this curve was only, you had a 15% of the area that you could pull the chunk out of. Now we're going to have a larger chunk of the area that we're going to pull the curve out of, or the data out of. Okay, so let's work on answering this question. Remember, the first thing that you're going to do is go to your unit normal table, and because we're talking about the z of 1.5, that's where you're going to go to look up your values. And so I'll go ahead and get our textbook to do that. Here we are now on page 649, and I'm over here because that's where our z value is in our table, right? There's our z of 1.50. But notice this time, when I go to look in my 3 columns, I'm not going to look in the tail for the proportion this time. This time, I'm going to look in the body. Why the body? Because I'm looking in most of the curve, not just a small chunk of the curve, but most of the curve. So when I go to look in the body, I find that I have this number of 0.9332. That's my number of interest because I've just gone to column B and I found that in that column there was that number. So that ends up being our answer. The way that we can kind of articulate this is we can say that there's a probability of pulling a z out that's smaller than 1.50, and that probability is 0.9332. Or we can say there's a 93.32 chance that you're going to pull out a z that's smaller than 1.5. Right? And you just want to notice how that maps on to what we're talking about over here. It looks like we have about 93% of the curve that could be potentially where we're going to get our x value from. Okay, so I do have one last example to show you to help explain this. And that last example now is where we're saying, what's the probability that I'm going to pull a z out that's smaller than a negative 0.50? So just to make sure that we understand what we're talking about here, first thing that we're doing is we're sketching out the curve that we're talking about with this problem. And this time, the curve looks like this. Right, so again, I just drew the S of the standard deviation row, but the reason why I did was because the Z values map right onto it. But what we're saying is we are interested in this Z of negative 0.50. And the question that we're asking is, what's the probability that I'm pull a Z out smaller than that value, right? So what's the probability that I'm going to pull a Z out from that part of the curve? I'll just kind of cut to the chase. Again, you are going to go to the tail to figure this out. It's a larger part of the curve than you had over here, but it's going to still be the tail of the curve because it's still less than half of the curve. Okay, so we go to our unit normal table. We look up our value of 0.50. Right, remember that we have a negative 0.50 that we're interested in, but the unit normal table doesn't have negative values, so we're just going to use this positive 0.50 as our source of information. And it's going to work just fine. Just remember that the part that we're going to is the tail. And when we go to the tail, we see a value of 0.3085. So with that, what that means then is that's our answer. There's a probability of pulling a z out that's less than negative 0.50, and that probability is 30.85, right? Or 30.85% of the curve is what we're talking about being able to pull a z out from. Okay, so that's everything I've got for this chapter. I look forward to working on these chapter 6 problems with you in the odd props. Have a great day.